Today's video is on transformations. We're going to go over the 4 different types of transformations. Make sure that you are taking notes on this information. Graph paper is provided along with this video where I've posted it. Just you can print it off so you'll have some graph paper to work with. It might be easier to take the notes on graph paper. You're going to want to pause so that you can take the notes, and then of course hit play to continue the rest of the video. And pause for each slide so you can get the notes taken. So first of all, translations. This is something that it looks like you slid the original figure is what we're talking about. So the example here is we're going to slide the original figure for -1. And what this means is we're going to move each point on the shape 4 units to the right and 1 unit down. Well, why is that? Remember that 4 is my x value. Right here, this is my x value in an ordered pair, and it's positive, so that means I'm going to go 4 places to the right along the x-axis. The -1 is my y value right here, which means I'm going to go down the y-axis, and that's why I'm going to, because it's negative. That's what we're doing there. So our first one here, we have the original coordinates of this shape. I have A right here. I have B right here, and I have C right here. So my original coordinates, A is -4, 4, because again, I went 4 places to the left, and then I went 4 places up, because again, X and Y. B is -4, 1, 4 places to the left and 1 up, and C is -1, 1. I went 1 place to the left and 1 place up. So what I need to do here is as I translate a shape is I need to make sure that number 1, I'm putting my new coordinates up, and number 2, I'm drawing the new shape. And then number 3, I need to write what are my new coordinates. So since I'm going to, I'm kind of sliding this, and I already said it's going to go to the right and it's going to go down. It's going to wind up kind of, again, to the right and a little bit lower than the original one. So where it's going to be, okay, the fancy thing I did isn't working, so we're going to have to do it by hand. So I'm going to go ahead and move these points. So again, A is going to move 4 places to the right. So I'm going to go 1, 2, 3, 4 to the right, and then I'm also going to go 1 down. So this is my new coordinate for A. We're actually going to write that as A prime. You're going to hear more about that in a minute. B, I'm moving 4 places to the right again. So again, it's going to land on the y-axis, and I'm going to go down 1. So actually, my new B is B prime, and that's there at the origin of our coordinate plane. And then C, again, is going 4 places to the right, 1, 2, 3, 4, and 1 down. So this here is my new C prime. And then all I'm going to do is connect my dots, and you can see that there's my new shape right there. So my new coordinates for this are right here. It's called the image. The new shape is called the image. And again, we're calling this A prime. The little hash mark there means A prime, and then B prime and C prime, because obviously we need to distinguish it from our original A and B and C. And that's how you would make sure that you note it when you go to translate a shape. So your new shape is the mapped image. That's another way you'll hear it. And it's going to be written as A prime, B prime, and C prime. So one of the things I want you to do now, and the question's not here, you'll need to make sure you write this on your paper. I want you to try to think of a rule. What would be the rule anytime that we are doing a translation like this, where we are sliding a shape? What happened to go from this original A value right here of -4, 4, what happened to get it to be 0, 3? See if you can figure that out for next class. Next one. These are reflections. Now reflections, these first ones are very simple in my opinion. I think you're going to have no problem. And again, this is also a review from 7th grade. So a reflection is like looking into a mirror. It can be over the x-axis or it can be over the y-axis. The example we're going to do here is reflect the shape over the y-axis. What's the easiest way to do this? Just count. That's all it is. Since we're going over the y-axis, you're going to count from there. This is where you might want to pause a second to take the notes. Okay, so all I'm going to do is I'm going to flip it over the y-axis. So I'm going to look at each one of my points. Again, this was A, this is B, and this is C. I'm going to look at each one of my points, and I'm going to reflect it over the y-axis. So one of the things I like to do is I like to highlight the axis I'm trying to flip over. So there's my y-axis right there, and I'm going to flip over that. That means that A has to be, right now, A is 4 units to the left of y. I need it to be 4 units to the right of y. So I'm just going to count from y, and again, 1, 2, 3, 4. This one right here now is going to be my A prime. That's my new mapped point. B also is 4 units from Y along the number 1 there. So from number 1, I'm going to go 4 to the right. 1, 2, 3, 4. This one is B prime. And C is only 1 place to the left. So now it's got to be 1 place to the right. That's going to be my C prime. And again, we're going to connect our dots to make our shape. Preferably, you're going to use a ruler. I don't have that option here. And so now there is my new mapped shape. And again, I have new coordinates for this. So my new coordinates are A prime, B prime, and C prime, as you see here. So again, the question is going to be, what do you think the rule is that what happened to flip this, so to speak? It's a flip or a reflection. What is my rule that changed it from A, my coordinates of -4, 4, to my new coordinates for A prime of 4, 4. In addition to that, what do you think the new coordinates would be if I were to flip this over the x-axis? If I went this way and took the original shape and flipped it over the x-axis this way. So think about that too and see if you can come up with a rule for both of those, for flipping over the y-axis and also for flipping over the x-axis. Okay, this transformation are rotations. Rotations get a little trickier, at least the 90-degree ones. They get a little bit trickier. I'm going to show you the translation, and then I want you to, again, think about what the rule might be, if you can come up with the rule. We're going to do much more of this one, especially with the 3 different kinds of rotations in next class. So rotation just means you can rotate the image, means you're going to turn it, and you can turn it 90 degrees clockwise. You can turn it 90 degrees counterclockwise, or you can also rotate the image an entire 180 degrees. Obviously, if you go 180 degrees, it's the same whether you go clockwise or counterclockwise. Remember that clockwise is sort of in this direction here, like as if you're watching the second hand on a clock. Counterclockwise is going this direction. And then 180 is literally a 180, as if you were going forward and you turned around and you went backward, you know, the opposite direction you just came from. So here, my original shape is, this is for a 90-degree rotation, on clockwise rotation. Okay, so 90 degrees clockwise. Here I'm going to take this shape and I'm going to literally rotate it 90 degrees clockwise. So that means instead of being here in quadrant 2, it's going to wind up in quadrant 1. The whole shape will be winding up in quadrant 1. And to do that, I'm going to kind of show you what it would look like if I were to just move the shape. And it's not letting me do it again. Okay, so I'm going to have to go ahead and draw the shape again. All right, again, this is going to be A, this is going to be B, and this is going to be C. For A to rotate, it's going to, the whole shape is going to turn, as well as A turning and B turning and C turning. But the whole shape is actually going to turn. So my A prime is going to wind up at 4, 4, which is right here. That's A prime. My B prime is going to wind up at 1, 4. This is B prime. And then my C prime is going to wind up at 1, 1, right here. This is C prime. So when I draw my shape, it now looks like this. So you can see that it turned in that direction. If we could physically pick it up and turn it, that's what a 90-degree clockwise rotation would look like. So again, let's look at our what our coordinates would be. That's our new image coordinates there. So A prime is 4, 4, B prime is 1, 4, and C prime is 1, 1. Try to think of a rule Again, for all these things, I want you to come back to class to tell me what the rule might be, but try to think of a rule for a 90-degree clockwise rotation. This one here is 90 degrees counterclockwise. So again, my original coordinates are the same as we did a moment ago. And since I'm going counterclockwise, I'm going in this kind of a direction. That means instead of my original shape being here in quadrant 2, it's going to wind up in quadrant 3. And just a reminder, this is quadrant 1, this is quadrant 2, this is quadrant 3, and then this is quadrant 4. So don't forget that. It acts like a big C if you think about it, right? If we went all the way around, it looks like a big C for coordinate plane. So on this one, since I'm doing it counterclockwise, again, this was A, this is B, and this is C. My A prime is going to be -4, -4. So this is now going to be my A prime. My B prime is going to be -1, -4. And then my C prime is going to be -1, -1, right there. So this is C prime. And again, when I connect my dots, you can kind of see if we were to able to pick it up and turn it, it actually kind of turns and would go right into that shape right there. So again, what are my new coordinates here? This is my new image coordinates. A prime is -4, -4, B prime -1, -4, and C prime -1, -1. So again, what happened to the original coordinates to get to these image coordinates? What do you think the rule might be? This one here, I'm going to tell you when you go to do the rule, I think you're going to find it pretty easy. This is my 180-degree rotation. So it's literally going to be the, almost like the opposite kind of thing. So since it's in quadrant 2, it's going to be all the way over in quadrant 4. And again, kind of just flipped all the way around, turned all the way around. So again, we have A, B, and C. Now my A prime is going to be 4, -4. So it's going to be right here. This is A prime. My B prime is going to be 4, 1. And then my C prime is going to be 1. I'm sorry, my B prime was 4, -1. And my C prime is 1, -1. So this is C prime. Oops, C prime. Okay, so again, connecting my dots. And you can see that that literally just flipped all the way around there. And those, now we have new coordinates for this. And there's my new coordinates. I think you might be able to see this one pretty easily on what happened with a 180-degree rotation. Also, with what I said, I kind of gave you a couple of clues. All right, the last rotation we're going to talk about here is a dilation. Now, a dilation literally either enlarges something or it reduces something. It reduces the shape. So it makes the figure bigger or smaller. Usually, it will be dilated around the origin. That's how they say it. And that means it's going to be dilated around the origin of 0, 0 on our coordinate plane. So in this case, it says to dilate the shape by a scale factor of 3. And again, my little fancy thing did not work. So I'm going to have to try to show this to you. So here we go. Okay, again, this is going to be A, this is going to be B, and this is going to be C. My A prime is going to wind up being -6, 6. So right up here, this is my A prime. My B is going to be -6, 3. This is my B prime. And my C is going to be -3, 3. And that is my C prime. So when I connect my dots like this, you can see that it was dilated, meaning it got bigger. Well, actually, excuse me, it could be bigger or smaller. But since it was a scale factor of 3, that means it's going to be getting bigger by a scale factor of 3. So along those lines, that should help you figure out how we got the new coordinates. There's our image coordinates. So see, again, if you can figure out a rule for when you dilate a shape. Think about not only when you enlarge, but also when you reduce. So not only when it gets bigger, but also when it gets smaller. Okay, the last thing you just need to know, a couple terms here, and we've talked about it a couple times. It's just to remind you what they mean. Origin is 0, 0 on our coordinate plane. Image is the new figure that is created by the transformation. And prime refers to the way that we notate the new coordinates. So A prime, B prime, C prime. All right, those are our notes for today. Again, make sure that you might want to watch it again if I went too fast for you or if you didn't pause. And do try to think of all the rules for doing each one of those kinds of transformations. What happened from the original coordinates to get the transformed coordinates? See if you can think of some kind of a rule, because obviously whatever you do for this one would hold true for every transformation of that kind. Next class, we'll be doing a lot more transformations, actually using graph paper and working on them on our own. Have a great evening.